for joining us today for another GraphGeeks talk. My name's Amy Hodler. We are lucky to have Michelle Yee on board with us today and presenting. Michelle, you can introduce yourself in full, but I'll say I've known Michelle for several years. She's, I would say, well known for having fun presentations and also has extensive experience in both graph and applied AI.
Yeah, thanks so much for having me, Amy and Dennis and GraphGeeks community. I'm really excited to talk about, I think, a fun little project that I did with graph and also embeddings. And this was actually, I originally started this project before ChatGPT came out, and then now there's like significantly more interest in this space. So so I have two components to the presentation, actually. One is the presentation format, and we'll kind of go through the background and inception of kind of how this project started, the methodology, and some of my original thinking behind it. And then I also have a notebook, and everything will be available for people to play with on their own in GitHub. And so, yeah, everything is open source for you. And so, today's topic is going to be decoding kanji. It's a fusion of word embeddings, similarity measures, and graph exploration. And I will also talk a little bit more about my background through kind of the story of how this project came about. Let me see here. Okay, so as I said, we're going to go through first kind of the background and goals, the general anatomy of kanji. I'm sure not all of you are familiar, like what the heck I'm talking about when it comes to kanji. I know Amy does because she actually, fun fact, studied Japanese for a long time. So, and then the methodology and sort of like some of the conclusions or insights that I found using this method. Okay. And so by way of background, so personally, my background is in computer science and mathematics all the way through grad school. I am more of a deep learning and AI kind of background by trade, as well as academically, and graph by passion. So that's how I sort of describe myself. I also speak 6 languages, and Japanese is one of them. And so that's sort of like this. I really wanted to kind of like play around with graphs and embeddings more. And this was a really fun way to break into that using my own personal passion for languages. And so I really wanted to discover kind of a few things with this project originally, and hopefully other people take this on and do other fun and interesting things with it. But one, I really wanted to understand whether or not there could be new insights into looking at the relationships between different characters or kanji, which again, I'll break down what exactly I mean by that. But like there's traditional methods of looking at kanji. So, and of course, kanji have been around since like ancient China, right? And so like this is not a new area, and there's lots of study and really interesting ways to look at these different characters, right? Like whether it's the classification or the root, and I'll share what all these components mean. But I really wanted to find like maybe there's like a slightly different way to look at it, and if we use these techniques, does that provide a different kind of insight into language? And I think, so Amy gave a talk previously, and this was not at all coordinated, on centrality. And one of the things I was particularly interested when I was looking at this project or thinking about the approach was, are there specific nodes of influence for kanji? Like, if we look at it this different way, do we see different communities being created? And like, does the power like shift to a power of meaning kind of like shift in any way to different words? And so, I'm excited to, as you can tell, I'm very excited to talk about this. And the third was really, like at the time, there wasn't as much, I would say, active interest in looking at this combination of like word or sentence. In this particular case, I'm actually working with sentence tokens and embeddings, but like there wasn't as much interest in like this combination of like how can we look at natural language with deep learning, but then kind of do graph analytics or network science on top of it, and like what's the utility of that? Like, so that was also a question in my mind, and I'm excited to share the results with you all. I'm very optimistic about the combination of these approaches as well, and so hopefully that's useful to the community. Okay, so I've said this thing like kanji a bunch of times, and you're probably like, what is this PowerPoint template and what is kanji? And so for those that are a little bit new, I'm not going to spend a ton of time going into this. I could probably give an entire lecture just on this. But just in terms of using kanji as data for the context of this project, I'll cover it. And so at the highest level, kanji are kind of like these characters that you see, right? And so originally they're from China, and of course China had a great influence on both Korea and Japan and neighboring countries, right? And you see a mix of kind of traditional Japanese alphabets as well as these Chinese characters. And so these characters are what are called kanji, right? And they can be in single characters, like one, like as you see in the middle, and they can also be combined. And I'll tell you, like I'll share kind of the scope of the project. I don't look at the like multiple kanji characters, right? So for this project, we're only looking at single kanji. And you'll see quickly it becomes a combinatorics problem in a way, because one kanji in the middle you see here is like idea, feeling, or meaning. But it's actually composed of like 3 different components, right? And so the typical way to break down a kanji is you have a root or like a radical, which is this bottom left. I'm like motioning as if you can see me, but yes, it's the bottom left where it says heart. And the radical typically provides a lot of the categorization and the meaning of a particular kanji character. And so the radical can be placed, you know, on the top, the bottom, the left, like there's different positions for it, and that influences the meaning of the combined character. And then you see that there's sort of like different components in addition to the radical that go into it. And these components are all characters on their own, right? And so the most basic characters, there's something, I think like 36 or so radicals. And then those are the most like broken down characters, and they go into a lot of different words. So I'll give a couple of more like fun examples that you can see that is simpler than this, but definitely check out if you're into learning languages or things like this. These are highly composable semantic types of words that are created and are very friendly for graphs. So, okay, so here's like a fun example to make it. I think the last one is probably a bit more complicated, but like, because I always like to have Easter eggs, I also have a controversial example. But so the fun example is like on the first one, you can probably guess what this means without even knowing it, but it means tree, right? And so it kind of looks like a tree, right? And so if you have one, it just means tree. And then you have 2 together, it's a grove or forest. And then you have 3, and it's like a really big forest. So like not all kanji are very, shall we say, intuitive like this. But I think this is personally one of my favorite characters. And when people, and each of these 3 are separate characters. But in terms of, so it's one of my favorite kind of meanings or sets of characters that I like to use when I explain to people sort of like how composable different parts of kanji really are. And so, and I think it logically makes a lot of sense. Like, oh, if you have 1 tree and now you have 2 trees, it's probably like a slightly bigger forest or grove. And then you have 3, it's a really big one, right? And so even if you aren't familiar with these kind of characters, no problem, right? Okay. So my controversial take, there's also for a fun Easter egg fact, actually one of the most controversial characters or radicals is actually woman, so on the left side. And so there's a ton of controversy, I think, probably in any or like many languages, in terms of like how women are historically described, because keep in mind, this is like from ancient times. And so if you really want to look into linguistic history, this is a fun one to dig into. But okay. So the core concepts for what we're going to look at, and then I promise we'll get more into like what the data set actually looks like and the analysis piece. But I think it's important to ground on these two concepts, because these are the main parts of what what I'm looking for when I did this analysis. So one is classification. Oh, and sorry, I forgot to update this one. Okay, I'll just talk through it. So one is classification, and I meant to delete those, but the second is meaning. And so for classification, as I mentioned, like kanji are classified by different sort of meanings, or the way that they generate the meaning. And so some are pictorial, like tree, and there's other ways of classifying them traditionally. So I wanted to look at what are sort of like the standard mechanisms of looking at kanji, and then like the new or like the different way that I wanted to look at it was actually by grouping them through their embeddings and the meaning of the kanji. So each kanji can actually have multiple meanings, right? And sometimes these are derived from the root, and sometimes it's derived from like a combination of things, right? Because there's not always an exact one-to-one translation. It's a one-to-many relationship, actually, right? So for example, like, I don't know, like one character can mean to like, to be peaceful, and to enjoy at the same time, right? And so each of the kanji have these multiple meanings, and it's hard to do an analysis using only traditional mechanisms to account for these like multiple meanings in a space. And that's actually one reason that like language models can really have a strength here. Okay, so let's talk about data, in case you also have a passion for wanting to look at this topic. And so if you go to this kanjidatabase.com, yes, there's an entire database for free that you can get all of your heart's desire, both for single kanji and compound kanji and all of that. So you can go here. It's free. It's the result of a study, I think funded by the Japanese government, and many researchers worked on this. And basically you can, I think they also have like a traditional SQL interface, but that I use, but you can also, I just use this kind of like clickable sort of field box so that you could see the range. This isn't even all of the fields available. There's more in case you want those, but you can see sort of there's a lot of different attributes that they capture about each kanji, and they do a very consistent and thorough job. So the first problem of getting data, I would say, is not an issue, because you can basically come here, query this database, and get whatever you want. And then, so in terms of scope, so I looked at single kanji, because like standalone kanji, instead of the like combined. So you can put, up to like 2 to 6 different kanji together to create words, to like more complex words. And single kanji, there's 2,136 characters, which in the context of a modern language model is not significant, but I found was interesting to look at from like once these were converted into embeddings and then translating into a graph is actually a pretty decently sized graph. And I'll show you more like how I go into that, but so yeah, as I said, not single kanji, or only single kanji, but not jukugo, which is the combined kanji. I also extracted all the all attributes, because I just wanted to see like if we group by meaning, then and then like try to maintain some level of attribute similarity as well. Like then what are the most central kind of nodes in that graph? Like, does that change from the classical interpretation of things at all? And then the key part, the key column that I was interested in was this meaning. And again, that has multiple fields and it can mean very different things. So for example, like road, the character for road, can actually translate into like journey, path, like not literally just a road, right? And so this is what I was really interested in honing in on, because it's like, how do you capture this one-to-many relationship, put that into an embedding space, and then look at the communities or centrality and things like that based off of this sort of context, knowing that each character has so many various meanings, some of which don't really translate well or at all into English. Okay, so let's talk methodology, and then we'll jump into a bit of code. And again, I just have it in a Colab notebook, and it'll be available for anyone to see. It's actually quite a simple approach, and so at a high level, and I have a nicer chart after this, but at a high level, it's really similar to density-based clustering, and it's on top of these word embeddings and combined with cosine similarity, which I think is pretty standard way to look at it. But it's the reason for doing this approach in particular, like there's alternative ways, and I'll talk about that, but was because one of the main things I wanted to do was to apply like graph analytics to it and to try to get different insights from it. And so if you look at, for example, like dbScan, which is a type of density-based clustering mechanism, this approach is really similar because basically where dbScan is a circle, like ours is an angle that basically is a cone. So like it's very, very similar to dbScan. But again, the key difference to this approach is going to be in terms of setting it up in a way that you can do the graph part on top of it, while also capturing kind of like the many meanings of each kanji, because there's not just one value. It's not a single token. All right. And I know some people might say, hey, but like, why not use TS&E? Like you can just do that to map into 2D space. Also a valid option. And you can, I've seen some like papers or analytics being done where people put that on top of or into a graph. But I think this is more interesting because it preserves slightly more information and in a way that's closer to dbScan versus compressing it down into 2D space. I will caveat this. So again, this because I think I mentioned I started this project a while ago. And then as I started to look into modernizing it a bit more since LLMs have come out, there's also new research in the space. So there's two actually that I would call out just because there's more up-to-date information you can also look at. And the slides will be in the GitHub. I haven't put them in there yet, but you'll be able to access these links. But one is a paper out of Netflix research, and they talk about sort of cosine similarity and the flaws, potential flaws and pitfalls associated to it, even though I think in the ML community, we've used this for a long time, like to get like similarity measures. But one thing, the key finding from this paper is actually that depending on how you do normalization during model training, you can that actually has a pretty big impact and influence on the cosine similarity measures. And actually in some instances, depending on how you do this regularization or normalization, the cosine similarity is actually not unique, which is a pretty big problem. So a very interesting paper. I highly recommend giving it a read if you are interested in this space. The second one is this survey, and I don't typically like a lot of survey papers, but I think these folks did a great job in terms of looking at large language models and generative like graph analytics in terms of both like building the graph generatively, but also like on the tail end in terms of like using a graph, right? So generation post graph and in applications. And so I think these are two papers I would call out that are not necessarily applied to this project, but should be. Okay, so let's talk process. Of course, I talked about, oh, I need to delete these two, sorry. But the process for collecting the data, I think I talked about, we just go to this kanji database. We basically do tokenization, and so you like originally this was using a BERT model. So on Hugging Face, you can go access any kind of BERT model. You can also use an LLM to do this tokenization. So pick your poison, you can tokenize it, and depending on what you want to do, obviously if you use a more modern LLM, you can do a lot more with the application than just this particular analysis. So that's a to-do, I guess, roadmap item. And then the third step is to apply BERT, or like, again, it could be a different large language model if you want to. There's also like Japanese specific ones that I am really interested to apply to this. And then when you do this application, what you do is you output and retrieve the actual encoded embeddings of the sentences. Again, because they're not word embeddings, because there's multiple meanings in a single kanji, right? And so because of that, I would recommend using sentence embeddings and not word embeddings. And then when you output that, you basically get a very, very long string of like basically a vector, but it's extremely long set of coordinates for these, right? And in addition to that, you have like the output includes like different columns of the original attributes. So those are all preserved. And that can all go into actually the graph part, which is the next step. You create the graph structure, and you can basically do any analytics, both in terms of the similarity measures, like in terms of the actual kanji, but then you can also do the graph analytics and the analysis component. Okay, so I think I talked a lot. So let's, I hope people are excited to jump into a little bit of code. I tried to do a good job of annotating my code. So let me just make sure, and let me know if you can't see the swap. But basically, oh, I also have the kanji database pulled up so you can see what this looks like. We'll go back to the slides to close out, but here's the GitHub repo where you can access everything, and then you can just do everything here in Colab. So if I make this
Michelle,
big,
we can see your notebook, but it's a little small. I don't know if you can increase the size just a tad bit here.
Let me see if I can.
While you're doing that, just for the folks on, I'll probably give it another 5 minutes, and then I'll start opening up so that you can get ready to ask your questions. And there's also a Q&A tab if you have questions, just stream of consciousness. Oh, there you go. It looks great, Michelle.
Is this big enough? Okay.
I think so. I think that's pretty good.
Okay, great. And again, the notebook will be available for everyone if you want to play with it. I also have the data uploaded too, so you can just, and please evolve the project beyond what I have. That would be great. But you can do everything here with just a couple of packages, pandas, NetworkX. I don't think I need to say more about these at this community. And you may wonder, oh, well, like, why didn't you use like tool? Why? It's just open source. I wanted to stick to open source tooling. And the graph wasn't so large that it couldn't, which is typically the problem with NetworkX, but it wasn't so large that this was an issue. And so once I have the sentence embeddings from like deep learning model X, again, in this case, BERT, but also I started to play with large language models and trying to tokenize it with, I think I was trying to use Mistral at the time. So, but I really want to play with the Japanese specific model. That would be interesting. But anyway, so once you have that, you load it in. I actually do the cosine similarity here within the notebook, so you can see how that's done. It doesn't, it'll take a couple of minutes to run, but it's nothing too significant. And basically here, I'm just trying, so this is all on the effort of constructing the graph. All right, and so I want to have the cosine similarity between every single embedding, because essentially the thing that I'm trying to answer is looking at centrality, like what are the nodes of influence and what are the communities that emerge that might be different from traditional analysis. So honing in on the meaning, again, of which there are multiple. And so basically then this is just like a filler function to make things easier on me later. And then basically I just structure the network here based off of a minimum similarity between embeddings. And you don't necessarily need to have like, for example, if something really has zero similarity, like you don't necessarily want to capture this in your graph, right? And so because we still want it to come out looking like I want to have visually the most important information, not necessarily all information. I use a couple of visualization packages, Matplotlib and CPAR, nothing fancy here. And then we have the graph. And so I think in this graph, we have a total of 268 nodes and 488 edges. And we can start to see kind of like some basic statistics about our network. And so, I think I ran this on a subset at that time, but yeah. And so kind of like, I think this is a pretty common, and again, I'm more of a deep learning person than a graph person. So feel free if you have feedback, but I think this is pretty common in general that a lot of real networks, like very from life versus kind of like synthetic networks, are actually pretty sparse or not that dense in the connections. And so like in general, there's a handful of nodes within this, which is actually what I wanted to be able to access the rest of the network. So this is actually what I wanted to find out. But and so on average, it only takes like 2 hops to get to like another step, and at most 5 steps. And so, yeah, this is just kind of like more analysis on and visualization about sort of like the sparsity of the network. And so you see that there's actually not that many that have a significant number of connections, but you see that there's a couple that have really high connectivity to the network. These are the couple that I'm interested in. I don't know what these are yet, so stay in suspense until the next line of code. And so the idea was that actually and this is sort of the hypothesis, that this is because that there's only a few hubs that connect actually the majority of the network of the 2,136 kanji. And so the most connected kanjis turn out to be, I know, suspense here. This is kind of like the big finding, was actually, path or road, which is this first one, has 238. And this character actually means like a village. But again, each character has many meanings. And so one of the meanings of village, yes, it literally is village, but it also typically is used to mean community, like network, which I also thought was kind of ironic considering our analysis, but also great for GraphGeeks. And then the rest kind of like are somewhere in a very average position with not that many connections. Like you see it drops down significantly to like 27 and then down to 5. And so some of these are like directions, that's east, this is north. Yeah, so which also kind of interesting, but you can see that, I mean, by far these two are kind of like, if you look at the meanings, they're actually the most well-connected kanjis. And so you can see, just to like look at it, and I have a lot of different ways of slicing the analysis to also kind of try to poke holes at it. And so like you can see here's the distribution of cosine similarities, and just like what are the closest kanji like with regard to cosine similarities. So like the most related one to, like, I thought this was interesting. If you look at the meaning that they share, so the 2 hubs, or like the 2 central nodes, have cosine similarity shared with the same character, which is kind of interesting. But I really wanted to see and then visualize later, like, what are the kanjis that have this most similar meanings with our influential ones. And so I think these are pretty interesting, just in terms of Like hand is one of them, which also means like it can also be used to mean like a goal, for example. So there's some, and then I was interested in the opposite. So what are the furthest away kanji? And I thought this was interesting. So the furthest away by meaning and definition versus just like the traditional classification of root is actually, so for road, the opposite or like the least closest kanji character is strength. So that's kind of interesting. I think it's kind of fun to think about like how language influences our like the meaning of general things in our communities as well, and like the way that we actually think about like different aspects of like human experiences and connections. So let's see. Then I also have a section here where I look at like different cliques, right? And so I don't think I need to explain these too much, but I just wanted to see like, okay, so if we look at different cliques, like, are there any interesting insights? So you can see like I do quite a bit of like different approaches to try to see if the results are consistent or different, or if I'm just finding some kind of, it's a very experimental way to see like, are my findings just a one-off fluke or are they pretty consistent? And across all of these different tests, they're generally fairly consistent. And then you also see kind of like, hey, I also use, so getting into centrality, I use eigenvector centrality. So this is another way to try to look at, like now that I have the different cliques, right, I try to apply this method to see what are the most important nodes in the network. And again, this, if you have a much larger graph like this, computationally can become rather cumbersome, but in this particular project, it doesn't take too long to run any of these things. And so, yeah, and so you see a consistent result as you said, nothing has actually changed here. And you see that there's a pretty high strength specifically for, again, road in this case, and which again, road also means like path or journey or future. Sometimes I think future is also one of the meanings that it has. And then village, which is again, community, network, and as well as like gathering, which is, yeah, I think it's pretty human. So yeah, then I do some community analysis and we're almost at the end, but basically like I also wanted to see like what do these communities look like as a whole, now that I understand kind of like what are the central nodes, and kind of like visualizing that too. I have a prettier visualization in the slide, but I should also try to use Kineviz at some point because I've seen some visualizations with that tool that look really amazing. But yeah, so then basically in terms of community, I want to understand like how dense are these communities around the influencers or like our influential nodes. And here I try a couple of different things. The main one is the Leiden algorithm. And then for evaluation, I did the Newman modularity. And so when I did the Leiden algorithm, you can see this is sort of like what an output looks like. You can see that there's sort of 4 different communities that come out of it. And then we do some evaluation. I think there's nothing too crazy in here. But basically, like the goal here was to find the tightly knit communities around these nodes, but also maintain attribute similarity. So remember, I had all those columns as well, not just cosine similarity, right? Because we want to maintain some level of the semantics. And we also want to understand like the homogeneity between these communities. Like, so are they, sharing like 5 attributes together or like 20? So those are sort of like the things that I'm looking for here. And then in terms of evaluation, because we should always test, testing's important. In terms of evaluation, there's like, I think I had, 41 different communities come out of this. And then again, we don't need to see every single community. Some have basically might as well be a 0 value, and those are interesting to us. And so I only saved ones that were greater than 50. And then I output this, and we can go back to slides. So if I go here, hopefully, there we go. And so then I made like a slightly nicer visual of these communities around the two hubs or influential nodes. And so if you look at the centrality here, you see this is the one for road, and you can see like there's a lot connected there: road, path, journey, and village. And then you can kind of see like at a distance, there's a couple of other nodes that kind of connect to these different hubs, but they're pretty small. Like by far, these are the most central kind of nodes. Okay, and then I will kind of wrap up. So I do think, so looking at the summary of results, if you look at the traditional way of breaking down these characters, you would not actually find that community, like that road and village are like the most influential nodes. That's not to say that the traditional ways are like not valid. They're definitely like built on hundreds of years of study, right? And so, but I do think it's interesting that when you look at like this aggregate meaning, and again, like that one-to-many relationship of a kanji character to like the modern interpretations of the word and how it's evolved over time. It's interesting to see that these two kanji are sort of the emergent ones. And so I don't know, I'm curious to hear your all's thoughts. If that makes sense? But I thought that for me personally, I thought that was fascinating, that it just seems like to make so much sense from the human experience side, like that those would be really important. Okay, and I did want to leave plenty of time for questions and comments, or like ideas if you have ideas on how maybe to better do the analysis or to evolve the analysis. There's some other things I want to do, like integrate like the Japanese language specific LLMs, and there's a lot of like newer techniques, I think, especially combined with graph analytics and things like that, and large language models. That would be really fun to explore. But yeah, everything will be in GitHub. I'll make sure I have the final slides in the GitHub repo as well. But yeah, feel free to explore. So yeah, thank you so much. And yeah, I appreciate everyone's time, and Amy and Dennis for this amazing community.
So thank you, Michelle. And I'm opening it up for questions with video. And so if people have their mics muted, their video muted, take them off if you want to actually verbalize your question. I have a ton of questions. That was so fun and interesting. And but I think one of the things, well, first I just want to say it really, for me, the way you went about it, there's a lot of exploration, and it just shows how much, like in data science, people think that you even know what question you're going to be asking, but there's just a lot of exploration and trial by error and seeing, what comes out of it. And so one of the things I've got a lot of question on like interpretation, which, I know you probably want a linguist to make real interpretations, but if there was anything, any surprises or potential meaning that you found, especially by like the clustering, it's like things are clustered. Does that imply that they're used in a certain way, or because they're used often together? But I don't know if you can answer that, but just kind of what surprised you, or what kind of meaning did you find from some of this?
Yeah, actually, so the main result to me personally was surprising, because I don't like, so I write and speak Japanese quite often, and it's not the case that I use these characters that much actually, but I thought it was really interesting that somehow they're still like the most relevant meanings overall. And when I thought about it, even though I'm not using those characters specifically, I was using, like I do use, rather, I don't know why I use past tense, but I do use very frequently, like let's say the second or third degree connection characters significantly. And so even though they're not like considered the most influential nodes on independently. For example, like I think the word roadmap is interesting. Like, so for example, if I'm talking to somebody, because I'm talking about work a lot of times. So if I'm talking about like, hey, let's build a roadmap or something like this, right? That's also ties back to actually this road, like path character in a way, even though I don't use that specific character. So I think those sort of ancillary, maybe it's part of the same community, but it's not the actual central node. I think that's maybe one insight I can share there. But I know you also studied, so you may have an opinion on, on some
Well,
of the kanji as well.
and I want to give other people a chance to answer some questions. But one of the things I would love to see, like another, I know this wasn't part of your original exploration, but if that kanji database has an element of of time introduced, like when that radical was introduced, changes over time, or how often they're used now versus used previously, the evolution of meaning, I think would be fascinating to kind of use this approach and then kind of look at that. So I'll just, just a little bit of extra work for you to do later, right? Like,
I love
but
that. Yeah, they do. They do. So they actually do, for FYI, if people want to take a look at that, they actually do catalog when the character was introduced, because not all characters are introduced at the same time. And they look at like decades of like newspapers, old newspapers. Like there's a ton in the data set that looks at that. I don't know if they capture changes in meaning, right? Like, for example, roadmap was definitely not a word back in like the ancient days, but so yeah, that would be.
so do we have some questions, people that would, and you can either just blurt them out, or if you want to use the hands up, that's welcome as well.
Yeah, I think I have something to say. Thanks, Mitchell. So just going through your slides, I was really, really excited because it also made me want to think something about the network of thrones. I know network of thrones has always been about, the main character, but now with what you've done with kanji, I'm starting to think that we could actually be able to like glean more insight as to the words and how they actually relate, and then maybe compare that with Harry Potter and some other classic books and genre to be able to see some words that are no longer being used as compared to, let's say, 10 years ago and present as well. So yeah, I think that actually gave me more insight on how some of this network science could actually be more looked at. Thanks, Mitchell.
Oh, thanks for the kind comment, Dennis. Yeah, it is interesting personally to. I think if you look at the like sentence level embeddings and not just word embeddings, I think that is one kind of different way or different aspect of this kind of project. And so, especially when you have languages, or I mean, English is the same too, right? Sometimes you have one English word that has like 10 different meanings depending on context. And so I think that is an interesting way to break that down. It's just more explicit in, I think, in something like kanji. But yeah, you can easily have like 20 different meanings or non-translatable meanings. And so I'm also excited to see like language models that are language specific as well. Yeah, because I think those will actually have way better results. And I kind of want to redo the analysis, but with a language specific model.
Awesome. And I think that Thomas might have had a question. Nope. No.
Yeah. So you sort of touched on this at the end there, and this is kind of the idea of concept drift, which can be like two things. One is a word changing meaning over time, and the second is a word being replaced by another word. For example, we no longer really see people using global warming. We see them saying climate change instead. That's changed over the last 15 years. For a language that is really old or has a long history, there's certainly got to be a lot of concept drift going on. And it sounds like you're kind of looking at the late stage of, now today. And you kind of brought up how it is interesting seeing, these other concepts that have kind of stood true to the test of time, let's say. How do you think you would go about telling that story of, here are the popular characters today, and here's how we got here? Do you think that's possible? Do you have any thoughts around that?
Yeah, I definitely think it's possible because I know that this particular data set is very well documented and curated over a extremely long period of time. Like we can't go to really ancient days, but we can go pretty far back. Like, yeah, like I want to say early 1900s in terms of like very good high quality data that's annotated and like documented across because they've done a lot of work also using computer vision models to like capture old newspaper articles and books and publications. And so it would be feasible for sure to go back and say, hey, let's conduct kind of like the same or similar type of analysis. And actually the controversy, there's this controversy about the character woman, by the way, is one of those that's changed significantly over time, right? Because back in the day, there were some pretty not so nice connotations that were used. And then now you don't see those characters being used at all in that way, right? Then so yay, progress. But you can absolutely do this kind of before and after. Now, concept drift in general is like a really interesting general problem for especially like the modern generative models, but in a much different context. And so like, how would you, if your question is also like, how would you capture this change live? I think that's a much harder question. Like how, yeah. And like the alignment needed with different human evaluation, I think that's very different. But that
I guess I was just going to say that it's just such a fascinating. Thank you, Thomas, for bringing up the question, because now I'm starting to think about concept drift. Even if you're not talking about immediate, like year to year or decade to decade, and when we go back and look at even things like old legal cases, and we try to infer meaning or use an LLM to answer a question that has like old old descriptions that are no longer valid today. How do you modernize those? And then the other thing, as you guys were talking, I was thinking, oh, concept drift and rewriting old literature. So, I mean, can you imagine rewriting Shakespearean literature with concept drift in it, or some of the old poetry out there that you try to read and you're like, I have no idea I don't know what this means, but you could, there's a whole, I can see this like whole genre of concept drift rewritten literature that would probably make many people upset, but would be interesting. Yeah.
Yeah, some of the humor really doesn't hold through over time, but like, but yeah, and thinking about too, like where does power and centrality shift over time? That's also a good question.
So do we have any more questions for Michelle?
Yes. I am having one question. So, Michelle, like you had one slide in which one of the steps mentioned that to focus on basically the structure of embeddings with original attributes, right? So, basically, what are those attributes? So basically, if I'm not wrong, attributes will be exactly the factors which will actually help us to understand that concept drift, because those will be the factors on which the respective embeddings, whatever is being generated for any kanji, that will work out, right? So how those attributes were derived, from where were they derived, or maybe I guess one of the things which I was looking out for in the slides were like kind of like a sample data examples which are already part of the kanji database. So that would have given me a more better picture to basically relate the things, because the examples are very valid, but being from the graph area, the semantics is what will play a major role, right? So if you can explain on this particular part, I guess it will.
Thank you so much for your question. Yeah. So the attributes I can share here really briefly again. Oh, here we go. Are basically all of these. I just didn't show the CSV. So in the GitHub repo, there is actually a CSV that you can see where all of the embeddings and the associated attributes are contained together in a single file. But just to give you like a short idea of like the different components that they have, I can bring this up again. So it's just, I mean, there's so many different attributes here. Everything from kind of like the radical frequency to frequency with proper nouns. I want to say there's also like when the character was introduced. They even have like entropy, like, yeah, how frequently the character is used in different positions. Yeah, there's a ton. There's meaning. Here we go. Year of inclusion. So they actually do flag kind of like when the character was included officially in the Japanese language as well. I think they even have the source, which is pretty crazy to think about considering how much effort it takes to document all of this. But yeah, so yeah, meanings of the different types of components, that there's multiple ways to interpret kanji as well. Reading. Yeah, so these are all of the different attributes that I included, and it's also going to be, it'll be in the CSV file, which is, it'll be here, so you can see kanji with bird embedding. So,
Okay, so basically the graph which you have shown is completely based on the attributes which you have just shown. Am I right?
yes, exactly. Yeah.
Okay.
Yep. Now, there's probably more creative things. I'd love suggestions on that in the community, maybe in Discord or wherever is convenient. There's probably other ways or like more creative attributes that we could actually add in. But yeah.
Yes. Actually, the thing is like, one thing is like, there are so many attributes which are there currently. It's very huge. So right now, some or the other way, some of the context will get covered in one of the attributes maybe. But whenever I think of creating a concept graph out of it, as in basically if it's one kanji, so if it is related to 50 other meanings, so how that meaning graph is coming up into the picture. So which will actually help me to actually visualize that graph, that formula is there, everything is coming out, but in the real life scenario, how that graph visualization of that single kanji and having that all the circle of graphs of the meaning basically will actually help a human to understand in more way. Like it's kind of like a low level and high level thing.
Yeah, that makes sense. Yeah.
Awesome. Well, thank you everybody for joining us. Thank you, Michelle. It's always fun to have fun with some of these, machine learning and the embedding and graph approaches, and just kind of, again, I think it's important for people to think about exploring things that and methods they hadn't thought about before, and not knowing actually where you're headed with your analysis, and kind of letting some of these visualizations and findings lead you to that next question or next idea. So I always appreciate that, and I always have fun with your presentations. It's just there's a nice whimsical quality about all of them. And I would encourage anybody who is part of the GraphGeeks.org community. There's a Discord channel. We're always looking for fun collaborations as well. So if somebody has an idea or a creative approach, as Michelle said, or just something different to look at and wants to work with somebody on it, definitely drop a note in the Discord, or reach out to Michelle or somebody at the GraphGeeks community, and we'll try to look further into it. So again, thank you, Michelle. Thank you everyone for joining. I always appreciate the questions afterwards. They're so interesting.
Thank you so much. Take care.